Streaming countrywide on Prime Media Plus.
On DSTV channel 885
and across the city
on 567 AM.
Good morning, Crystal Audison standing in for Clarence Ford on Views and News. And now it's time for our regular Friday conversation with the very interesting naked scientist, Dr. Chris Smith. Good morning, Dr. Smith. How
Good morning.
are you?
I'm very well, thank you very much. And yourself?
Good, thanks. Thank you for joining us. It's always interesting when the questions start coming in now. The first question that I have, hi, doctor, and this is from Andre. Why is Africa on the bottom of the world atlas? Who decided it, on whose authority?
Who made the maps is the answer to that. You end up with the telephone dialing code number 1 if you set up the first telephone network, America. You end up with yourself on Greenwich Meridian, time zone 0, if you invented the concept of time zones, the UK, Greenwich. And if you made maps and you were the early explorers, which Europeans were, they realised the Earth was a ball, a sphere, and they had some idea of where the countries were. So they started just plotting them in a way that was logical to them. And they thought, well, we're upwards, and when I walk around, my head is pointing upwards, so therefore my country must be upwards. So they put their countries at the top of the map, and they put other countries that they knew less about at the bottom of the map. And it sort of stuck. But really, because the Earth is huge and the curvature of the Earth is so gentle, when you walk across the Earth, you think you're always upwards wherever you are, because relative to you, everything looks flat. But in fact, you're, as we all know, walking around a circle. So when you are at the South Pole, you're upside down relative to where you are at the North Pole. But who says what's up and down anyway? Because we're just a ball in space. And in the grand scheme of the universe, there isn't an up and down as far as we're concerned. It's just a ball in space.
So we have a voice note.
Morning, guys. This is for Dr. Chris Smith, a naked scientist. I'm Logan from Edenville in Johannesburg. I just want to know if there was water on one of the moons of the gas giants. For example, you can choose any one of the close to habitable moons. What would the effects of the gravity of the other moons and the gas giant itself be on the tidal energy? So what would the waves look like on one of those moons if there was water?
Hi, Logan. Well, it's really interesting that we think that, or you're asking about this, because we think there is water there. And in fact, not just think, we've got pretty compelling evidence that these gas giants have moons that have a lot of water. And we're sufficiently convinced of this fact that people are spending a lot of money sending probes to visit. In the past, they've done Cassini, which visited Titan, the largest moon of Saturn. But while it was there, it had a brush with another moon of Saturn called Enceladus. And what it spotted about Enceladus was that this moon appeared to have a hot spot on its south pole, or hot bottom, I suppose you could say, the Beyonce of the moon world. And it then flew through the plumes that were coming out of this, because this hot bottom was a giant geyser. And it was spewing out spray. And this was salty water, the instruments aboard Cassini told us. And since this has also been replicated around another planet, Jupiter, with its moon Europa, which is, I think, the 4th biggest moon of Jupiter and the 6th largest moon in the solar system. These pretty big bodies. But why are there hot water geysers on these fairly small moons? And the answer is that we think that because they are very close to the parent body, and these gas giants are massive, therefore they exert a big distorting effect gravitationally, and because the moons do not go round in a perfect circle, they are feeling a greater and lesser gravitational attraction on their orbit, and this has the effect of stretching and squeezing the moon a bit, and this has the effect of causing frictional heating inside the moon, or tidal heating, and this keeps water at liquid temperatures, and in some places is sufficient to make the water spew out as these giant geysers. So the answer is that there are sufficiently big tidal forces exerted on these moons by these massive planets that they orbit to A, keep water from freezing in what would otherwise be a minus 200 degrees C environment. We know that it's minus 200 C because if you go to Titan, Saturn's largest moon, there's liquid ethane, which is a carbon atom and a few hydrogen atoms different from methane, natural gas that we burn on our gas stoves, and it's cold enough to keep that liquid. So we know that there's that there, and we also know that it causes the surface to ripple and buckle and this is making the water move a substantial amount inside that moon if there is an ocean there, which we think there is. So pretty compelling, and it's convinced NASA to send the Clipper Europa mission, which is going to blast off later this year, to go and visit the moon of Europa in order to appraise these plumes that are coming out and see what's in them and if there's any evidence of life there.
Les from Westlake with a question. Good morning, Les.
Hello, morning.
Go ahead with your question to
My-
Dr. Chris.
My question is, the other day I bought a dozen eggs from a supermarket that all contained double yolks. So my question is, how did the farmer know, or are they engineered that way?
Oh, hi, Les. Well, I don't think the farmer does know. You could scan the egg. You could have a look because you can transilluminate the egg. If you shine a bright light through, you can see enough, I think, to just about see what's going on inside. That's how you tell when eggs have got chicks growing inside them, for instance, by this process of transillumination. But I doubt the farmer knew that. It might just be a batch of chickens were doing that. And the reason that they double yolk sometimes is that the egg doesn't form as an egg and then put the yolk up inside the chicken. What happens first is that you produce the egg, which is the future chicken with its albumin, the white, and the yolk attached to the thing that can be fertilized, the egg proper. And then as this comes down the oviduct in the chicken, it's invested in the calcium-rich shell that then enables the egg to come out as that perfect little incubator. And so if a process inside the hen puts two embryos up there, or future chickens together, and they get wrapped up together, then you'll end up with a double yolk egg, and you'll get twin chicks. You could have two chicks in there potentially. It might be that that's a foible of those particular birds that's doing that. I don't know. Any chicken farmers listening can help us out. That would be nice.
Thank you, Dr. Chris. We do have a voice note. We're just looking for it. But Dr. Chris, I have been interested in I always wonder with all the missions to the moon, is it because countries are trying to be the first, or are they doing it for scientific reasons?
Oh, both, both, definitely, because there's an advantage to being first to anything, pretty much. Apart from dying, perhaps you could argue there's fewer advantages to that. But being the first to get somewhere, launch something, own something, means that you then have winner advantage. And if you are there first, you control the landscape. And the reason people are interested in the moon is resources, because the moon has ready access to a range of different resources, which will be useful for doing things like building things in space, living in space, and launching space missions from space. And also strategic advantage for looking at the heavens and doing astronomy. And if you control the resources in the best places, then you're likely to have an advantage over everyone else who's an also-ran, aren't you? So all of the above is the answer. There is scientific endeavour behind this, but there's also a lot of commercial interest and strategic military interest.
Conversation with Dr. Chris Smith, also known as the Naked Scientist, who joins us weekly on air to answer a variety of science-related questions. Dr. Chris, now we've been struggling with slow internet over the past few weeks because of undersea cables. What is your understanding, and explain to us how these undersea cables work? Because we have about 3 along West Africa, and then 2 East Africa, and then some of the cables snap.
The building or installation of the Peri-Africa network made a huge difference to internet access across the continent, because until that chain of connections, which goes all around the coast and then sends spokes inland to service all of the countries, which then relay those connections onward inland, really there was a paucity of good quality connectivity across the continent. People were relying on satellites, for example, and other less high quality routes of transmission, or very expensive modes of transmission. And so having these fibre optic routes in was very, very much a game changer. And that's happened in the last couple of decades. But of course, anything that's in the ocean is vulnerable, and anything that has to go across land to get to another country means that that third party is vulnerable, because the cable can be damaged, it can be also sabotaged at any point along its journey. And that was why the way that it was crafted was such that you had lots of spokes coming in lots of different directions, and it therefore meant that if you cut this in one place, it shouldn't compromise services elsewhere. And it's the same with the ring mains in your house when you supply electricity. If, in theory, if you cut the cable in one place, because it's on a ring, it should still mean your sockets are serviced and will still work while you track down the fault, although people are going away from that sort of mode of doing wiring these days. So the answer is that these things do fail because they're vulnerable on land and they're also vulnerable under the ocean, but the resilience of the internet, with traffic being able to be routed via a range of different journeys across the internet, should help to keep things going, which is why it might slow down. And the reason it might slow down is because if you block up one road, the traffic has to take alternative routes. There are still routes to get where the traffic needs to go. Your car's on the road. They're taking all the back streets. They might be making longer journeys with more kind of stop-offs required, and this introduces more time overhead, which is why things arrive, but they arrive more slowly, and there's more congestion because you've got fewer routes for the traffic to go down, so they're overusing the routes that are still patent, and that's why things go to a crawl when you block off some of the main streets.
Dr. Chris, now in South Africa, we are hosting, of course, with the site of the Square Kilometre Array. Now, this year is quite pivotal because they're due to complete the construction of the first antenna this year. Talk to us about why this, as we call it, SCAR, is so important and is such a game changer, not only for Africa, but for the world.
Well, the Square Kilometre Array, which was approved more than a decade ago now, the bid was contested between Australia, Western Australia and Southern Africa, because the bulk of it's in South Africa, but there are also parts of the telescope proposed for other countries bordering South Africa to the north. And the vision is that this will give us a telescope with seeing power, which is probably 100 times more powerful than anything we've had before. And this is because you are looking at something which it's basically a telescope with a collecting dish the size of a country rather than the size of a car. And this means, in space terms, size really is important. It means that you are going to be able to see far farther and in far more detail than ever before. But this is not going to be nice, glitzy pictures like the Hubble Space Telescope generates. This is a very different kind of astronomy because this is radio astronomy. And it will enable us to see at very long wavelengths. And this means we can see clear pictures way back in time across the universe as light has stretched out to become much more long wavelength, and also in longer wavelength regimes that are less frustrated or interrupted by the kinds of things that can make visible light astronomy more of a challenge. So this is a big step forward for Southern Africa because there are a number of hurdles that the researchers have had to overcome in order to build this technology, which is, well, how do you have the computing power to process the amount of data that's going to flow off this thing? It's more data flowing off this thing than the whole world was producing in its entirety in a year, will come off each day. Historically, about 10 years ago, those numbers were true. Obviously, the world's producing a lot more data now, but it's still a huge data problem, a transmission problem. You have all these different telescope units because it's not one single telescope. It is distributed units, which are over several thousand kilometres of space in the Karoo and so on. And those will pick up data and then have to coordinate when they saw each individual bit of data they picked up and timestamp them and bring them together. So it's a big data collection and data transmission problem. And then it's a scientific endeavour problem. You've got to have people, you've got to have trained people who can use and run this instrument. And that's a great win for Southern Africa because where's it based? It's based in Southern Africa. Where will the data be processed? And you need the experience and the people in Southern Africa. But because it's in Southern Africa and the world wants to share and use that instrument, it will be a huge draw for space scientists to come to Southern Africa or collaborate with scientists in Southern Africa and especially in South Africa in order to use the instrument. So it's a win on many levels, this.
A voice note.
Good morning, Clarence, your views and news team, Dr. Chris. I asked this last week, but I didn't get on even though I tried early. I'll try again. I've got a bit of a dilemma of mixing powders. The one powder is all of 2 micrograms, the other 300 milligrams. That gives a factor of 150,000. So my question is, how do I mix it successfully without having to use tons of the 300 milligram ingredient so as to weigh the lesser one accurately, which is obviously not easy. I'd appreciate a response. Dion Tarot.
Hello, Dion. I'm sorry you didn't get on last week, but you found that being patient and persistence pays off, and that's always the true in science, isn't it? Persistence pays off. Well, you're right. When you've got something which is in vast excess, and then something where you have a tiny amount, the error margins of what you weigh out are going to really make a difference to the small thing rather than the big thing in terms of the percentage error. And it all comes down to the precision and accuracy of the device that you're using. So you have to choose a weighing device which can be accurate within the tolerances of what you need it to be. And if you're down at the sort of milligram or microgram level, then you need something that's going to deliver an ability to be accurate to the thing which is the smallest thing in what you're trying to measure. And so it will come down to the precision and accuracy of the weighing scale that you're using.
Very interesting. So another question, Dr. Chris. Why can my remote open my car door through a wall, but my TV remote needs to be pointed directly at the device without any obstruction? Shad.
Hi, Chad. Lovely question. And the reason is because they use two totally different wavelengths of radiation. A TV remote is usually infrared. In other words, it's light waves which are just slightly longer than red light that we can see. And that kind of light, as you know, visible light, doesn't go through walls. And infrared light, which is otherwise known as heat, also doesn't go through walls. It bounces off the wall, or warms the wall up, which is why you feel warm in your room. But radio waves, on the other hand, can go through the wall, and the wall is effectively invisible to radio waves. It's a bit like glass. You can see visible light comes through glass. It's not opaque to that form of light. And your remote control for your garage and your car and so on will go through a wall because those radio waves have a totally different wavelength. They're longer, actually, than the visible light that's coming out of your remote control for your TV. And the longer wavelength, the more stretched out waves, thread their way through what the wall is made of better than infrared does. And that's why the range is much longer, and you can open and close the car, open and close the garage and the gates and so on with a radio transmitter, but not an infrared one for your TV.
Very much, Dr. Chris. And we just have a lovely message from Cliff of Parklands. He said, blessed Dr. Smith, blessings to you and family and friends. You must one day come to South Africa and come have a local braai so that people can ask all the questions they want, Dr. Chris. So this is just a message of appreciation from Cliff about the great work that you do and always the insights that you're able to share with us here on Cape Talk.
It sounds like an invitation rather than anything else. So thanks, Cliff. Next Friday, all Cape Talk listeners around Cliff's house.
Great stuff. Thank you.
See you soon.
Dr. Chris.